Assalamu alaikum sir. I am Mithila Surur Mehta from the Department of CSC and this is my final term OBE assignment. This assignment is about digital parking system that can automatically track how many cars are in the garage and indicate whether space is available. The system should count the number of cars entering and exiting, display full when the parking lot is maximum capacity, blink space available when space is available, use 7-segment display and control logic built from counter, sensor and timers. As you can see, the maximum number of cars in the garage can hold is calculated from my student ID, which is 235043001. The formula is given, which is A plus G plus H. And here, if I had a zero from any number, then we should be replaced it with A plus B plus H. So let's start answering. This is the block diagram of my system. It includes entry and exit sensor to detect car movement, a 4-bit up-down counter built from flip-flops to track the total number of cars, a comparator to check whether the counter has reached 9. If the count equals 9, the system activates a 7-segment display which is show full. If the count is less than 9, the display shows space available controlled by a blink timer. Two separate 555 timer circuit are used to manage the display modes. Here is the flowchart that represents the logic of the parking control system. First, the system is initialized and the maximum capacity is set. Entry and exit sensor monitor car movement. When a car enters, the counter increases by 1. When a car exits, the counter decreases by 1. A comparator continuously checks the values. If the count is equal to the 9, the system shows full. Otherwise, it shows space available in a blinking pattern. This ensures that the system always reflects the current ability status. Here is 4-bit synchronous up-down counter for entry and exit sensor. The counter increase on detecting the raising edge from the entry sensor and decrease when the exit sensor is triggered. Since the maximum value is 9, a 4-bit counter is sufficient. The internal architecture contacts each flip-flop with clock signals and use logic gates for enable and resetting. A comparator monitors the output and determines which display logic to activate it. And this is the equation for up-down counter, and also I write a block diagram here. In this page, we can see there are two type 5 timer. One is for astable mode and one is for monostable mode. One timer in monostable mode keeps the full display on constantly. The other is astable mode, blinks the space available message. Let's calculate the timing parameter from my ID. I calculate P, which is 14, frequency 10, duty cycle 0.6. Then the time is 0.1 second, which is 100 millisecond. Then I calculate TH and TL also. So and that time I used C equal to 215 microfarad and calculated R1 R2 values based on 555 timer formulas. These values gives the desired blinking outputs. The full circuit simply use a latch to keep the signals high. So the question is why I use C equal to 215 microfarad. In 555 timer, astable mode generates specific blinking rate for the space available display. Here I have three options: 15 microfarad, 215 microfarad and 417 microfarad. Here if I use 15 microfarad, the resistors values are very large in difference. And if I use 417 17 microfarad, then the register's values are very small in difference. So I selected 215 microfarad, which is a middle grounded value, neither too small or neither too large. This is values are currently same difference. In this phase, I designed a finite state machine with a clock period of 1 millisecond. According to the instruction, if TH or TL are more than 4 milliseconds, they are kept at 4 milliseconds. So my FSM includes 4 states for signal A on for 4 milliseconds and 4 states for signal B off for 4 milliseconds. The FSM cycle through this state repeatedly. I included a state diagram, state table, and an equation for outputs and a Verilog HDL codes for output A and B. The FSM ensure accurate controls of the blinking display. So here are the last topics of this assignment: limitation and modifications. There are few limitations. The counter is limited to only 9 cards due to the 4-bit design. There is no manual override or reset option. Sensor delay could cause counting mismatch. To improve the system, use a 5 or 6-bit counter for larger capacity and microcontroller based control for flexibility. Introduce enable and reset logic for the 555 timer. Use multiplex display for more efficient output. Thank you.